Math time! I don't know how to take this seriously. Can I go now? Lacey is...
Sorry, continue.
Lacey is filming me filming this. Welcome to 1.3, solving equations with variables on both sides. This is where it gets real. We've finally made it into big kid math, where we are solving equations with variables on both sides. All it really means, though, is we add one little tiny step to something you can already do quite well. Of course, let's underline our central question. So if you guys would do that with me, how can you solve an equation that has variables on both sides? Not too big of a deal if you follow steps. It makes it easy for you. So for our first activity, we need to do a little review on what in the world perimeter and area is. We've worked with these things in the past, but just in case we've forgotten, I need you guys to write a few little notes. If you remember, perimeter is the distance around something. If you were to build a fence around a rectangle, how much fencing would you have to buy? All the way around. So we can write a little equation to remember this in the left side of our paper. So P, that stands for perimeter. Now let's see. If we were to, say, do the perimeter of letter A here, we know that we would have to add up the width and the length, and then we'd have to add up the width again, which would be 3, and then we'd have to add again the length, which would be x. So that we know for a rectangle, we have 2 widths, and we add that to 2 of the lengths, and that gives us our perimeter. Now if you guys remember, area is not around, but area is how much is inside. So if we were to divide this up into little squares of values of 1 unit and by 1 unit, to find the area, we would end up adding together all of these little squares, of which we'll do the math for later. So area is how much is within something. So a quick way to do that is to just multiply. We could count them all, but that would take forever. Or we could multiply the width times the length. Area equals the width times the length. Now for this activity, they set things up with some unusual figures. This isn't normal that it works out this way, but for our benefit, it does. So they say work with a partner. Each figure has an unusual property that the value of its perimeter, so it's all the distance around, the number that's the distance around, is equal to, ooh, good math language, the value of its area, so the amount inside. So that number of area for perimeter. Interesting. This is some good information. So they tell us here, write an equation that is the value of perimeter equals the value of area for each figure. So let's do this for our very first figure. They give us tons of room underneath. Let's take advantage of that. So we know for this figure that the value of the perimeter, or P, equals the value of A, the area. Let's fill in the blanks. As we saw from up there, we know the equation for area and the equation for perimeter. So let's plug in the equation for perimeter. See what it looks like. We know that perimeter is 2w plus 2l. So we plugged in perimeter. Now let's plug in the equation for area, which we know is w times l. So we plugged in a set of variables. We've substituted a set of variables from another set of variables. We went from p to 2w plus 2l and from a to w times l. We can go one step further. Every single one of these figures for activity A is going to start with this part right here. You could even just write that down with the p equals a, then the 2w plus 2l equals w times l. Now we fill in the relevant information. What is the width for this figure? So we can write down 2 parentheses, so we'll fill in the blanks later, plus 2 parentheses. equals parentheses times parentheses. Let's fill in our information. W is 3. L is just x in this case. W again is 3, and L is x for the length. If we simplify this, it looks like 2 times 3 is 6 plus 2x equals 3x. Now this is something we're a bit more familiar with. However, there are variables on both sides. This is the key point to today. Always move your variables to the side that has more. It'll make up your mind for you every time. It's always easier this way. Move your variables to the side that has more. If you get to class and say, hey, I moved my variables to the side that has more, I will give you a high five. So which side has more? Well, on the left side, we have 2x. On the right side, we have 3x. There are more x's on the right side. So let's subtract 2x from each side. So minus 2x and minus 2x. 2x minus 2x is 0, so we're just left with 6 on this side equals, and the 3x minus 2x is just 1x, or x. And we found our variable. X equals 6, or 6 equals x. To double check that we did this correctly, we can plug in our variable x and see if it's right. If the area is the same number as the perimeter, then we've done it right. Let's do the perimeter. If we have 3 plus 6 plus 3 plus 6, or adding up all the sides, another way to write that would be 2 times 3 plus 2 times 6. Simplify, we have 6 plus 12, or 18. That means the perimeter is 18 if we add up all the distances on the sides. Let's see if the area is the same thing. The area we know is the length times the width, or the 6 times 3, and that equals 18. So it looks like the perimeter does equal the area, and we did it right. Let's do the same process for each and every one of these. I'll help you set these up, and then you can fill in the details. Underneath of this, we can start with P equals A. Then our equation for perimeter, 2 times W plus 2 times L. And then our equation for area, length times width, width times length. It's the same thing. Then fill in our details. We have 2 parentheses plus 2 parentheses equals parentheses parentheses. Looks like our width is x and our length is 4. Really, it doesn't matter as long as you're consistent. And then again, our width is x and our length is 4. I expect you guys to be following along so I can see that you did your work, not just answers. So do copy all this down. Simplify, we'll have 2x plus 8 equals 4x. And you see how I switched those two around? It's okay. It's much better to write 4x than x4. You always write your numbers first and your variables after. All right, which side has more variables? Looks like the side on the right does. So let's subtract 2x minus 2x. That cancels out, so we're left with 8, and 4x minus 2x is just 2x. Last step, we just need to divide both sides by 2 because we're trying to get x by itself. 8 divided by 2 is 4, or 4 equals x. If we plug it in, we'll see that 4 times 4 is 16, or if we add up all the sides, 4 plus 4 plus 4 plus 4, that also equals 16. How unusual. We find ourselves here again. Write out the same thing. Underneath each of these, I need to see a P equals A. I think you have 2 times length plus 2 times width. See how I switch those? Does it matter? Nope. Equals length times width. I decided that I want to do alphabetical order. It's more orderly that way. Now let's plug in our relevant details, but first we'll go 2 parentheses, parentheses, plus 2 parentheses, parentheses, equals, parentheses, 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 parentheses. Fill in our details. Let's go. Our length is 18. Our width is x. Our length is 18. Our width is x. That's simplify. 2 times 18 is 36 plus 2x equals 18x. This is our extra step that we're adding, is which side has more x's. The right side does, so we'll subtract 2x from both sides. You guys might be seeing a pattern by now. 2x minus 2x is 0. It cancels out, and 18x minus 2x is 16x equals 36. Now we divide both sides by 16. And that cancels out. Looks like we don't have a nice fraction over here, but let's find a common multiple, and we'll do some simplifying. I know that 4 goes into 16 quite nicely. 4 also goes into 36. 4 goes into 36. 9 times 4 goes into 16. 4 times that equals x. Let's check our math and see if we did it right. Let's find the perimeter. So that would be adding up 2 x's. So that's like saying 2 times 9/4 plus 2 times 18. 2 times 9/4, 2 times 9 is 18, then divided by 4. Or actually, you could do 2, you could simplify 2 and 4. 2 divided by 2 is 2, 4 divided by 2 is 2. So this looks like 9/2 plus 36. 9/2 as a mixed number, if you must know, is 4.5. And 36 plus 4.5 is 40.1/2. Now, let's do, this is for the perimeter. Let's do what the area equals. Area. Do length times width. So, what if we did 18 times 9/4? Quick way to simplify this is divide both the top and bottom by 2. So 18 divided by 2 is 9. 4, the bottom divided by 2, is 2. And on top we have that 9 that's still there. 9 times 9 is 81/2. And if you divide 81 by 2, or 80 by 2, that's 40, with the 1/2 left over. 40.1/2. Huh, who would have thought that would have been right? Last one on this page. I think you guys can do it. I think you can do well. I'll help you set it up. Remember, we have P equals A. We have 2 times length plus 2 times width equals length times width. Plug in our relevant details. 2 parentheses, parentheses, plus 2 parentheses, parentheses. You see how I'm doing this every time? That means you too can show your work every time. And we have 2 times our length would be x. 2 times our width would be 5/2 times 2. Then we have x and 5/2. Simplified would be 2x. And 2 times 5 divided by 10 is 5. Or these 2's just cancel out. 2 divided by 2, and we're left with 5. So yeah, that's the same thing. 2 times 5 is 10, divided by 2 is 5. Or the 2's cancel out, and we're just left with 5. Equals, do 5/2 x. Now, in this case, which side has more x's? Well, if you turn 5/2 into a mixed number, you'll see that that's 2 goes into 5 twice with another remainder half, so that's 2.5 is actually bigger. So let's subtract 2x from both sides. Minus 2x. And so we're just left with a 5. 5 times 2 is 10. Equals x. If that didn't make sense, watch it again. The more this makes sense to you, the more easier, better your homeworks are going to be. This is some big league stuff. We're not joking around. However, our equations may have just gotten a little bit longer. Now, if you can see here, the whole perimeter of these figures together, not including this part, that's not a part of the perimeter, it's just a little line that's there to show that it's two different shapes. Same thing for over here too. Is the same as the area of both of these things combined and put together. So we're going to need to put those equations together. Screwed up the first time. Good thing I get to do some redos and help you guys out before you make mistakes. My job is to help you make as little mistakes as possible and to fix them when you do. So let's do this correctly. If we have a perimeter equals area, just like every single one, we have to add up this perimeter a little bit differently. So let's take a look at what's going on. We know that all the perimeter are the places where they give us numbers. X, 3, and so on. And there's a few places they don't give us any numbers. So we can start writing those in so we have a reference. On the opposite side of x would be another x. Over here in this little corner, we have on the opposite side of 1, it's just 1. Now let's say, if we see here that this length of our scribbled line would be 2, just like we wrote down, but the length of the whole thing is 3. Now, so what would that make this little tiny part here? Well, that would just be 1 as well. 3 minus 2, and our leftover is 1. Let's add up all of our sides. So we have, starting from the top x and going clockwise, we have x plus 3 plus x plus 1 plus 1 plus 2 plus 1. That's everyone. Let's simplify this before we go any further. So we have 2x's, 2x, then all of our numbers. 3 plus 1 is 4, 5, 2 more is 7, and another one is 8. Plus 8. Now let's get our area. Our area is just going to be simple. It's going to be the combined area of both of these rectangles. So we have in rectangle 1 times 2, which is 2. And then we have in rectangle 2, x times 3, or plus 3x. Now it's as easy as getting our variables to the side which has more. Subtract 2x from both sides because the left side has 3 minus 2x. And 8 equals 2. 3x minus 2x is just 1x, so x. And subtract 2 from both sides, just like we used to. And we're left with 6 equals x. Ooh-rah. To see if this checks out, we can plug it in. It does. I hope you still have plenty of room left. All right, now we need to fill in all the places we don't know the value on this f thing. So starting down here at this 2, on the other side of 2, we have a 2. On the other side of this 4, we have a 4. And that gives us everything we need. Let's add them all up. So our perimeter equals, let's start at that same 2 again. 2 plus x plus 2 plus 2 plus 4 plus x plus 1. Let's count our numbers. We have 2 plus 2 is 4. Another 2 is 6. Plus another 4 is 10. 11. 11 plus 4 is 15. Plus one more will be 16. All right, so our perimeter equals 2x plus 16. Now let's find our area. Our area is very easy. We can write that just right here. Our rectangle 1 will be 2 times x plus, here we would have 4 times x plus 1. Now they did something here that we haven't met yet, is we're going to have to use some distributive property to simplify this. So 2x is good as is, but we need to look at, here we have to distribute the 4 through the parentheses. So boom, boom. 4 times x is 4x. 4 times 1 is just 4. Combine like terms, we get 6x plus 4. This equals our area. Let's drop down our perimeter. All right, which side has more x's? Surprise, surprise. It happens to be the right side all of these times, but it's okay. Subtract 2x from both sides to move the x's over to the side who has more. So we get 4x plus 4 equals 16. Oop, running out of screen. Good thing they have all this extra room down here. Subtract 4 from both sides. And we get 12 equals 4x. And my friends, what does x equal? Divide both sides by 4. And 3 equals x. I hope you feel smart, because you look smart. Take a breath. We have activity 2 next, which is very similar to activity 1, but we've upped the ante a little bit. We're going to be working with surface area and volume for each figure. Now, I'm going to write down some equations here, and we're going to copy them down to the other page as well. Remember that surface area is the area of all the faces on the outside of a 3D figure. Volume is all the stuff that's on the inside. So it's sort of similar. However, we're going to have a bunch of figures where, again, they have the unusual property, it doesn't happen every time, that the surface area is equal to its volume. So let's remember what the equation for surface area is. Imagine we have a cube right here. And we can't see these other sides back here, but they exist. Now, we can see 3 sides, right? We can see the length, the width, and the height of this little cube. We know if, let's say we were to number these, we can say side 1, side 2, side 3. We know that the area of square 1 is height times length. We know that the area of side 2 is height times width. And lastly, we know the area of side 3 is length times width. Lastly, we know the area of side 3 is length times width. Now, if you guys know how many faces are on a dice or on a die, like you use to play in a game, there's 6. So on each one of these sides is its inverse exactly equal side over here, 2 and 3. So we know for each of these areas, there's one more. So we do 2 times height and length, plus 2 times height and width, plus 2 times length and width. Now another equation that, if you know this and remember this, I'll give you a high five for that too, is volume. If we have another 3D shape, and we were to try to fit as many cubes in it as possible and count them up, what we would do is we'd first get how many cubes we knew could fit along the bottom, how many cubes we could fit along the length, and then how many cubes high it was, and then we'd be able to count all those cubes that made up this figure, stuffing all those cubes inside. Now, instead of counting them, a unique way that we can figure this out would be to just times the height times the length times the width, and we get our volume. So if you remember that, good for you. If you don't remember it, we'll write this down because we're going to be using it on the next page. Oh, Gully, did you find a monster? On the top left of your paper, I want you to write down the equations we just figured out. We had surface area, which was Kelly!
Gully, come. Shh. Come here.
2 times the height and the length plus 2 times the height and the plus 2 times the height and the width plus 2 times the length and the width. And we also remember that volume is just height times length times width. So underneath of our figure, we can write the same thing. Surface area, or just SA, equals volume, V. Write out our whole equation. 2 times height times length plus 2 times height times width plus 2 times length times width equals height times length times width. Let's write down, let's plug in the values that we know. So we have 2 times our height, which is x, and our our length, which we can say is 6, plus 2 times our height and 2 times our width, which is 6, plus 2 times our length, which is 6, and 2 times our width, which is also 6, equals height, which is x, times our length, which is 6, and our width, which is 6. A lot of numbers, but we keep ourselves organized and we can do this. So we have 2 times x times 6. We can multiply. And 72 divided by 12, which we just did, 6. So we have over here 6 equals x. Yay, we found it. So we found a 6 by 6 by 6 cube. Letter B, I will get you as far as the equation and you will have to simplify and solve. So we have SA equals V. Surface area, remember, is 2 times height times length plus 2 times height times width plus 2 times length times width equals volume, which is height times length times width. Let's fill in all of our details. So we have 2 times parentheses 4, which is our height, and we can do our width as x, or we do length as x. Why not? Plus 2 times height again is 4, parentheses, and then our width is 8, parentheses 8, plus 2 times length, which we decided was x, times width, which is 8, equals 4 times x times 8. Please simplify and solve. I think you will probably move your variables over to the right side. Hooray, hooray, this video is long enough. I want to do activity 3 in class with you guys. There's a few different ways we can do this, which I think will be much easier to explain in person. Last thing I want you to do is, in your own words, right? Can you solve an equation that has variables on both sides? What is the most important part to that? I would not like you guys to write an equation, so I will cross that out for you because I don't want you to do that. I will see you in class. Thanks for following along.